11, 12. Negative 12 is a point. Okay, but that's not my only 0, is it? Okay, so what do I have to do? I have to find this other 0, because we have 2 answers. Okay, so let's tell the calculator again to go second calc 0, number 2. I can just press number 2 and it will go right to this operation here. Now, I'm over here, but I'd like to be over here. So we do our right left arrow, we scroll right. This takes us along the function. I can hold it down as well. Just hold it down and it comes over to this other 0. Now, in order to show left and right, remember it's now looking for a left bound. Okay, it's asking me, tell me where is the left boundary of the 0 you want me to find. I'm on this function and here's where your cursor is now and what is the left boundary. And this would be a good spot to stop. I mean, I just stopped here and you can see my flashing cursor. It's because this is the point I want to find and I'm to the left of it. So I'm going to enter that. And it has given me an arrow to show me, okay, we're going to look to the right of that. And then, so now where is the right boundary of where you'd like me to look? So we'll scroll to be above the x-axis where y is positive. We are now above the x-axis, so the calculator knows look in here, so I'm going to enter that. Okay, so we have 2 arrows saying, okay, look in here, please, for a 0. And would you like me to guess? Yes, we do. We always want to round it off answer if necessary. Okay, and this isn't rounded off. It's a nice integer, 2. So when x is 2, y is 0. And that makes sense. Again, if I put in a 2, 2 plus 5 is 7, and the absolute value of 7 is 7. So that checks. Okay, so let's graph that. So when x is 2, y is 0. Now, there's a whole bunch of other points, you know, like where does this turn? That just happens to be where it, you know, where it's a 0, where it crosses the x-axis when y is 0. But part of this exercise tells me to graph and label the solutions on the graph. So what could I do? Well, here is a good, easy way to do it is go to second table where we get a list of numbers here. And if I go to x is negative 12, notice here also, when x is negative 12, y is 0, and I can plot all of these points. We can see they're going negative 1, negative 2, 3, 4, 5, 6. They seem to be going down until we hit what number? Negative 5. At negative 5, so negative 5, negative 7 would be a significant point. Negative 5, negative 7 is roughly here. Okay, and so now really I just have to kind of connect those because these are linear. I don't need many other points. Certainly more points would make it more accurate, no doubt, but we'll just graph these best we can here. Stop there. Okay, these do continue on forever, so I am going to put arrows at the end. And this is the function y equals the absolute value of x plus 5 minus 7. Okay, so we have a solution at x is negative 12. Negative 12, 0 is a solution. And we have a solution at x is 2, 2, 0. If you check that, negative 12 plus 5 is negative 7, and the absolute value of negative 7 minus 7 equals 0, which is our y value. And at 2, x plus 2 is 7, and the absolute value of 7 is 7, and 7 minus 7 is 0. So those check out on our function, and on our original function too, which, of course, can't hurt to check that either. Okay, I'm going to just erase this and look at the next one. The next one we're going to look at is number 7, which is 2x squared minus 3 equals negative 5x. So I'm just going to get this ready for the next one here. Okay, now here's where we have what's called a quadratic. It is degree 2. And so it's a second degree function. And so if you ask yourself, like, what do second degree functions look like? They're parabolas, right? So we know this. So it is possible that this is going to cross the axis either no times, 1 time, or 2 times, up to 2 times. 2 roots or 2 zeros would be the maximum number of zeros we could get, or roots from this function. So once again, it's very simple. We're just going to make this a 0. So we're going to add 5x to both sides, and I've done that here. You see that I put the 5x in the middle here. You see that this is x to the 2 power, or 2x to the 2 power. This is x to the 1 power, and this is x to the 0 power. So they go in descending order, 2, 1, 0. The exponents on the variables go in descending order. This is called standard form. Okay, so it is a good idea to write that. Although, if you put in the calculator with the plus 5x at the end, it's not going to change what the calculator understands that to know. So that's fine. I just thought I'd review that. Okay, so now here we are. This is where I left off. So I can just go to y equals, and I don't want that in there. But now I just want to show you something. If I don't really want to take this out of my calculator just yet, and I'd like to put it into y2, I'm going to enter this function into y2, which is 2x squared, 2x, and the squared is, there's two ways to do squared. You can either touch this button, which is x squared, which will do that, or, whoops, 2x, and you can raise to the power with this button here, which is caret. Okay, now of course if it's just squared, they have a nice button here, which often we use that, so they give us a button, but if it's any other power other than 2, you have to use the caret with the 2, or 3, or whatever the exponent is. Okay, either one is fine. Plus 5x, again, these don't have to be in this order, but I put them in standard form, minus 3. Now you'll notice that both of these y1 and y2 have a black box there, right? And I just want to show you what happens when I graph this. It's graphing y1 and y2, which is okay. Looks kind of cool. We can find where they intersect. That's another fun little thing to do. But really, I don't really want to see the y1 function right now. But I don't want to erase it because it took me time to put it in there. So I'm going to go back to y1. And all I have to do is scroll over to that little equal sign and enter that so that it is no longer dark. So I didn't have to take it out because I might want to look at that later on. And now when I graph, it's only going to graph the one we want. Now you'll also notice that before, in the last example, we changed this so that the x axis went to negative 15. We don't really need that now, so I'm just going to show you how to change that back. There's two ways to do it. One is to go back to your window and make this a negative 10 again. And then look at your graph, and now we're back to a symmetrical picture that's a negative 10 by positive 10, negative 10 picture. The other way to do it, I'm going to just go back and make this a negative 15 again where we came from. Okay, so we had this off center, which again, it's not a problem. I'm just showing you how to do it. We go back to the zoom. So zoom, we can zoom in, we can zoom out, we can do all these things, but Z standard, the number 6 function here, I can either press the 6 or scroll down to 6 and enter it. I'll just press 6. This recenters it and makes it once again, I'll show you once it stops, back to a 10 by 10 window. Okay, so zoom standard, if you ever want to get back to the 10 by 10 window, just go to the zoom button and hit number 6 and see zoom standard. Okay, so back to the problem at hand. We have now entered into y2 in this example, this function 2x squared plus 5x minus 3. We have set our window back to a 10 by 10 window. And now what is it we're trying to do again? Remember, we want to know where does this function equal 0? Okay, well this function equals 0 once again when we are on the x-axis. Okay, so if we're on the x-axis, we are here and here. So there are in fact two solutions to this problem. So we're going to tell it second calc 0, which is number 2. Okay, and now we're back to the screen. Now you'll notice up here on my calculator anyway, it says y2, 2x squared plus 5x minus 3. That's the function that I have entered in y2, and that's the function that this cursor is on right here. It's flashing right there. I'm at the point 0, negative 3, so I happen to be on this function at the y-intercept, which is negative 3, which of course is part of this equation right here. When x is 0, y is negative 3. That's my y-intercept. I'm not that interested in the y-intercept at the moment, though. I'm interested in the zeros, in where is y a 0, which is when I'm on the x-axis. So once again, it's asking me what's the left bound I want, so I'm going to scroll to the left so that I get to the left of this point, which in this case happens to be above the x-axis. I'm going to enter that, and I'm seeing my arrow to say, okay, you want me to look to the right of that? What's your right boundary? And this again is just where my cursor is. So I'm going to scroll to the right of that, and now I'm to the right of it, which happens to be below the x-axis, so I should see a negative number on my y. And I'm going to enter that, okay, so these two arrows now are telling me, okay, calculator saying, okay, so you want me to look in between here, and that is true. Okay, so and now it says guess, and so I want it to just give me an approximate number if that's necessary. Okay, so this is very interesting how they gave me this. Okay, so this calculator right now is saying, you'll notice this, it says, this is not what it did when I practiced it, but it's saying it now, and this is a limitation of the pixels on my picture. This cursor right now is at the point -3, 0, but the 0 they're having here, they're writing in scientific notation, but this number 1 times 10 to the -12 power is so small, it's a 0. But due to the limitations of the pixel on my screen here, they don't have a 0 there. They have this. I don't know why that is, to be honest, but that's a 0. So this point is at -3, 0. Now, if you're like not really sure, you could certainly look at the table. Okay, and let's go to -3. Okay, so do you see here at -3, when x is -3, y is 0. So I'm actually kind of glad that happened just now, because don't be thrown off when you see that. I have to go through the process again to get my calc back up here. So number 2, I need a left bound. I need a right bound. I don't know if it's going to do it again. I'm going to guess. Yeah, it did. Okay, so if you're getting a y equals this number, remember that's in scientific notation. It's extremely small because 10 to the -12 power is very small. And it's so close to 0, but it's just a limitation of the pixels, which are the little boxes that make up this screen. And so it doesn't seem like it can get on a 0, but that's okay. We know that's 0. We asked it to give a 0, and so that's 0. So -3, 0 is one of my zeros, one of the solutions here. So I'm going to graph that. -3, 0 is right there. Okay. Neat. All right, let's try the second solution, which of course, second calc. I want a 0, so I'm going to choose number 2. I'm going to scroll over to the left boundary. It's asking me for a left bound. And as long as I'm below the x-axis, I'm at the left boundary, in this case. Now I want to come above the x-axis, so y should be positive. Okay, I'm going to enter that. And now you'll see, okay, I have my 2 arrows. It's going to look in here for a 0. It's going to give me an approximate answer if it needs to round it. So now my 0 is at it is at 0.5, which we know is a half, and y is 0. So this point, you can see it's sort of flashing in there. It's a little convoluted. Now, you know what? Maybe let me just show you how you kind of scroll in on that a little bit so you can see it better, because all that looks a little convoluted. So we're going to zoom in. No, sorry, it's not second. It's just zoom. Number 2, zoom in. So I'm going to press 2. Now, you'll notice that I have a very tiny flashing point right here, and that tells me where I am. It's very small. I would like that to be closer to this right here, so I'm going to scroll down a little bit. I'm not on the function right now. I can be off the function, so I can scroll in on this point right here if I'd like to. I can zoom in on that, but I really want to zoom in on this area here because I want to see where this half is. Okay, so it's like almost like I got closer with the microscope. So here's 0, here's my origin, here's 1, and here's half. And if I want to use, now I can use second calc to find this now, number 2. And I need to go to the left and to the right and tell me what that is. So it is a half 0. And I can see it a lot better now because I've zoomed in. And there's 0 and there's 1 and there's a half. Okay, so I'm just going to go back to the standard screen, zoom number 6. This is the standard screen, 10 by 10. Okay, now let's go back to how do we graph this thing? Well, we need some points to graph. So once again, I'm going to go second table to get a list of points to graph. And I know that at -3 I have a 0. Okay, and then I also know that at 0, y is -3. That's a good point to graph. But I also know at 0, y is -3, right about there. But I know I have a turning point down here somewhere, right? Didn't we have a turning point over here somewhere? I can actually find that. I'll show you real quick how to find that turning point. It's second calc, and I would like to know the minimum. So I'm going to choose number 3. And there could be more than one minimum, so I'm going to scroll to the left. It's very